Drivable 3D Gaussian Avatars. We present Drivable 3D Gaussian Avatars, D3GA, the first 3D controllable model for human bodies rendered with Gaussian splats. Current photorealistic drivable avatars require either accurate 3D registrations during training, dense input images during testing, or both. The ones based on neural radiance fields also tend to be prohibitively slow for telepresence applications. This work uses the recently presented 3D Gaussian splatting, 3DGS technique, to render realistic humans at real-time frame rates, using dense calibrated multi-view videos as input. To deform those primitives, we depart from the commonly used point deformation method of linear blend skinning, LBS, and use a classic volumetric deformation method, cage deformations. Given their smaller size, we drive these deformations with joint angles and key points, which are more suitable for communication applications. Our experiments on 9 subjects with varied body shapes, clothes, and motions obtain higher quality results than state-of-the-art methods when using the same training and test data. DMV3, D, Denoising multi-view diffusion using 3D large reconstruction model. We propose DMV3D, a novel 3D generation approach that uses a transformer-based 3D large reconstruction model to denoise multi-view diffusion. Our reconstruction model incorporates a triplane NeRF representation and can denoise noisy multi-view images via NeRF reconstruction and rendering, achieving single-stage 3D generation in approximately 30s on single A100 GPU. We train DMV3D on large-scale multi-view image datasets of highly diverse objects using only image reconstruction losses, without accessing 3D assets. We demonstrate state-of-the-art results for the single-image reconstruction problem, where probabilistic modeling of unseen object parts is required for generating diverse reconstructions with sharp textures. We also show high-quality text-to-3D generation results, outperforming previous 3D diffusion models. Our project's website is at Project's website. Single Image 3, D, Human Digitization with Shape-Guided Diffusion. We present an approach to generate a 360-degree view of a person with a consistent high-resolution appearance from a single input image. NeRF and its variants typically require videos or images from different viewpoints. Most existing approaches taking monocular input either rely on ground truth 3D scans for supervision or lack 3D consistency. While recent 3D generative models show promise of 3D consistent human digitization, these approaches do not generalize well to diverse clothing appearances, and the results lack photorealism. Unlike existing work, we utilize high-capacity 2D diffusion models pre-trained for general image synthesis tasks as an appearance prior of clothed humans. To achieve better 3D consistency while retaining the input identity, we progressively synthesize multiple views of the human in the input image by in-painting missing regions with shape-guided diffusion conditioned on silhouette and surface normal. We then fuse these synthesized multi-view images via inverse rendering to obtain a fully textured high-resolution 3D mesh of the given person. Experiments show that our approach outperforms prior methods and achieves photorealistic 360-degree synthesis of a wide range of clothed humans with complex textures from a single image. EDMSound, spectrogram-based diffusion, models for efficient and high-quality audio synthesis. Audio diffusion models can synthesize a wide variety of sounds. Existing models often operate on the latent domain with cascaded phase recovery modules to reconstruct waveform. This poses challenges when generating high-fidelity audio. In this paper, we propose EDMSound, a diffusion-based generative model in spectrogram domain under the framework of elucidated diffusion models, EDM. Combining with efficient deterministic sampler, we achieved similar Fréchet audio distance, FAD, score as top-ranked baseline with only 10 steps and reached state-of-the-art performance with 50 steps on the DeCAS 2023 Foley sound generation benchmark. We also revealed a potential concern regarding diffusion-based audio generation models that they tend to generate samples with high perceptual similarity to the data from training data. Project page. Project's website. Routing to the expert. Efficient reward-guided ensemble of large language models. The complementary potential of large language models, LLM, assumes off-the-shelf LLMs have heterogeneous expertise in a wide range of domains and tasks so that an ensemble of LLMs can achieve consistently better performance. Existing ensemble methods for LLMs mainly focus on reward model ranking of outputs, leading to significant computation overhead. To combat this issue, we revisit the complementary potential of LLMs and further elaborate it by mining latent expertise with off-the-shelf reward models. We propose Zooter, a reward-guided routing method distilling rewards on training queries to train a routing function, which can precisely distribute each query to the LLM with expertise about it. We also integrate a tag-based label enhancement to mitigate noise from uncertainty when using rewards as silver supervision. Zooter shows computation efficiency in inference as it introduces only a minor computation overhead of a routing function compared with the reward model ranking methods. We evaluate Zooter on a comprehensive benchmark collection with 26 subsets on different domains and tasks. Zooter outperforms the best single model on average and ranks first on 44% of tasks, even surpassing multiple reward model ranking methods. UnCommonsense reasoning. Abductive reasoning about uncommon situations. Language technologies that accurately model the dynamics of events must perform common sense reasoning. Existing work. Evaluating common sense reasoning focuses on making inferences about common everyday situations, to instead investigate the ability to model unusual, unexpected and unlikely situations. We explore the task of uncommon sense abductive reasoning. Given a piece of context with an unexpected outcome, this task requires reasoning abductively to generate a natural language explanation that makes the unexpected outcome more likely in the context. To this end, we curate and release a new English language corpus called UnCommonsense. We characterize the differences between the performance of human explainers and the best-performing large language models, finding that model-enhanced human-written explanations achieve the highest quality by trading off between specificity and diversity. Finally, we experiment with several online imitation learning algorithms to train open and accessible language models on this task. When compared with the vanilla supervised fine-tuning approach, these methods consistently reduce lose rates on both common and uncommon sense abductive reasoning judged by human evaluators. GRIM, Graph-Based Interactive Narrative Visualization for Games. Dialogue-based role-playing games, RPGs, require powerful storytelling. The narratives of these may take years to write and typically involve a large creative team. In this work, we demonstrate the potential of large generative text models to assist this process. GRIM, a prototype graph-based interactive narrative visualization system for games, generates a rich narrative graph with branching storylines that match a high-level narrative description and constraints provided by the designer. Game designers can interactively edit the graph by automatically generating new subgraphs that fit the edits within the original narrative and constraints. We illustrate the use of GRIM in conjunction with GPT-4, generating branching narratives for 4 well-known stories with different contextual constraints. Fusion-Eval, integrating evaluators with LLMs. Evaluating large language models, LLMs, is a complex task, especially considering the intricacies of natural language understanding and the expectations for high-level reasoning. Traditional evaluations typically lean on human-based, model-based, or automatic metrics-based paradigms, each with its own advantages and shortcomings. We introduce Fusion-Eval, a system that employs LLMs not solely for direct evaluations, but to skillfully integrate insights from diverse evaluators. This gives Fusion-Eval flexibility, enabling it to work effectively across diverse tasks and make optimal use of multiple references. In testing on the SummerVal dataset, Fusion-Eval achieved a Spearman correlation of 0.96, outperforming other evaluators. The success of Fusion-Eval underscores the potential of LLMs to produce evaluations that closely align human perspectives, setting a new standard in the field of LLM evaluation. Pearl, personalizing large language model writing assistants with generation-calibrated retrievers. Powerful large language models have facilitated the development of writing assistants that promise to significantly improve the quality and efficiency of composition and communication. However, a barrier to effective assistance is the lack of personalization in LLM outputs to the author's communication style and specialized knowledge. In this paper, we address this challenge by proposing Pearl, a retrieval-augmented LLM writing assistant personalized with a generation-calibrated retriever. Our retriever is trained to select historic user-authored documents for prompt augmentation, such that they are likely to best personalize LLM generations for a user request. We propose two key novelties for training our retriever. 1. A training data selection method that identifies user requests likely to benefit from personalization and documents that provide that benefit. And 2, a scale calibrating KL divergence objective that ensures that our retriever closely tracks the benefit of a document for personalized generation. We demonstrate the effectiveness of Pearl in generating personalized workplace social media posts and Reddit comments. Finally, we showcase the potential of a generation-calibrated retriever to double as a performance predictor and further improve low-quality generations via LLM chaining. SiRA, sparse mixture of low-rank adaptation. Parameter-efficient tuning has been a prominent approach to adapt the large language model to downstream tasks. Most previous works consider adding the dense trainable parameters, where all parameters are used to adapt a certain task. We found this less effective empirically using the example of LoRa, that introducing more trainable parameters does not help. Motivated by this, we investigate the importance of leveraging sparse computation and propose SiRA, sparse mixture of low-rank adaptation. SiRA leverages the sparse mixture of expert SMOE to boost the performance of LoRa. Specifically, it enforces the top K experts routing with a capacity limit, restricting the maximum number of tokens each expert can process. We propose a novel and simple expert dropout on top of the gating network to reduce the overfitting issue. Through extensive experiments, we verify SiRA performs better than LoRa, another mixture of expert approaches across different single tasks and multitask settings. Llamas know what GPTs don't show. Surrogate models for confidence estimation. To maintain user trust, large language models, LLMs, should signal low confidence on examples where they are incorrect, instead of misleading the user. The standard approach of estimating confidence is to use the softmax probabilities of these models, but as of November 2023, state-of-the-art LLMs such as GPT-4 and Claude V1 3 do not provide access to these probabilities. We first study eliciting confidence linguistically, asking an LLM for its confidence in its answer, which performs reasonably. 80.5% AUC on GPT-4 averaged across 12 question-answering datasets, 7% above a random baseline, but leaves room for improvement. We then explore using a surrogate confidence model, using a model where we do have probabilities to evaluate the original model's confidence in a given question. Surprisingly, even though these probabilities come from a different and often weaker model, this method leads to higher AUC than linguistic confidences on 9 out of 12 datasets. Our best method composing linguistic confidences and surrogate model probabilities gives state-of-the-art confidence estimates on all 12 datasets. 84.6% average AUC on GPT-4. Thread of thought unraveling. Chaotic contexts. Large language models, LLMs, have ushered in a transformative era in the field of natural language processing, excelling in tasks related to text comprehension and generation. Nevertheless, they encounter difficulties when confronted with chaotic contexts, for example, distractors rather than long irrelevant context, leading to the inadvertent omission of certain details within the chaotic context. In response to these challenges, we introduce the thread of thought (THOT) strategy, which draws inspiration from human cognitive processes. THOT systematically segments and analyzes extended contexts while adeptly selecting pertinent information. This strategy serves as a versatile plug-and-play module, seamlessly integrating with various LLMs and prompting techniques. In the experiments, we utilize the PopQA and EntityQ datasets, as well as a multi-turn conversation response dataset, MTCR, we collected, to illustrate that THOT significantly improves reasoning performance compared to other prompting techniques. UT5, Pretraining Non-autoregressive T5 with unrolled denoising. Recent advances in transformer-based large language models have made great strides in natural language generation. However, to decode K tokens, an autoregressive model needs K sequential forward passes, which may be a performance bottleneck for large language models. Many non-autoregressive NAR research are aiming to address this sequentiality bottleneck, albeit many have focused on a dedicated architecture and supervised benchmarks. In this work, we studied unsupervised pre-training for non-autoregressive T5 models via unrolled denoising, and shown its state-of-the-art sauté results in downstream generation tasks such as squad question generation and XSOOM,